So one way that we've been estimating the area under a curve between the curve and the x-axis on an interval has been using rectangles. But rectangles aren't the only geometric shape that are used to approximate the area under the curves. Often we start with rectangles or we'll go to rectangles automatically because they're very convenient shapes, right? Their area formula is really simple to use, right? It's just base times height and you just add them all up. But the downside to using rectangles is that they don't often fit very well under the curve in those little subintervals that you make, right? Because functions don't often have very horizontal sections on them, which means that the tops of your rectangles aren't going to fit perfectly or even very closely under the curve or even slightly above the curve. So another shape that we frequently use is going to be a trapezoid. So let's remember what a trapezoid looks like and how to find the area of it. So the area of a trapezoid is 1/2 the height of the trapezoid times the sum of the bases, which we'll abbreviate as B1 and B2. So let's make sure that we know what a trapezoid is. So a trapezoid, right, is just a four-sided shape. It's a quadrilateral where two of the sides are parallel, and those are the bases. The parallel sides are the bases, so we'll call this base 1 and base 2. And the height is just the perpendicular distance between them. So we're going to use that to find the area of a curve. So we're going to go back to the same function that we were evaluating in our Riemann sum video. So let's go back to that function. So we're going to go back to finding the area under the curve, or I guess I should say approximate the area under the curve. And we were using 2x squared over the interval 0 to 2. Using trapezoids and 4 equal subintervals. So let's see where this gets to. So first thing I'm going to do is draw another one of our, just a little picture, right? Always nice to have a graph. Make it nice and big. So we want to try and figure out that area. So we're going to use 4 equal subintervals, so that means our delta x here is going to be, right, 2 minus 0. We're going to take the length of our interval divided by the number of subintervals, so we'll get that each partition should be 1/2 unit long. Right. So all I'm going to do is I'm going to split this into 4 trapezoids. So I'm going to color code them so it's a little easier to see. So the first trapezoid is actually going to be a triangle. I'm going to use my straight line tool here. Now, of course, this curve is going to be a little different just because I hand drew the curve, so it's not going to be totally accurate because we're going to only be so accurate with hand drawing. Close enough, it's fine. We're going with it, it's fine. Okay, so we can see our 4 trapezoids are there, and these are trapezoids that are rotated, so the height of them is actually going to be our delta x. So the height is this distance here. So this here is going to be our height. And then the bases are the parallel sides, so we'll let this be base 1 and base 2, and that would be going all the way across. So as we go to find our area, right, we're just going to find the area of each trapezoid and add them together. So the area of our first trapezoid would be 1/2 times the height of 1/2 times the sum of the bases. So the bases here, this would be f of 0 and f of 1/2. So we'll add those two together. And then we're going to add that, right? So then we'll have the second trapezoid is 1/2 times the height of 1/2. And now those bases are f of 1/2 and f of 1. Whoops. Right, and then we'll just keep going. So our third trapezoid, right, the formula is 1/2 times the height. And the bases of the purple trapezoid are 1 and f of 1 and f of 3/2. And then our final one is 1/2 times 1/2. And then the bases of that trapezoid are f of 3/2 and f of 2. So this is a lot, and if you were to have more than 4 subintervals, this might be a little cumbersome. So if we look at this, right, they all have 1/2 times 1/2 in front of them. So I'm going to factor that out front, right? So 1/2 times 1/2 is going to give me 1/4. So that's our factored out part. And then if we leave what's left over on the inside, we have f of 0 plus f of 1/2. And then we would have, I'm just going to copy and paste because that seems easiest, right? Just taking all of the stuff that's left inside. Not mean to do that. There we go. It's totally fine. Okay. All right, so we have all of this. So then we can see that some of them have been doubled up, right? So we have, oops, just a parenthesis in there, right? So our middle 3 lengths are all doubled up. So if we were to actually write this in a way that might be simpler to type into our calculator, we have f of 0 plus 2 times f of 1/2. Plus 2 times f of 1, plus 2 times f of 3/2, plus f of 2. And it's great to condense it like that because if you are going to type it into your calculator, or even if you're doing this by hand, it makes the number of calculations and sums that you have to do a little bit smaller. So if you want to go ahead and type that into your calculator, you can. If you want to try it by yourself, go ahead and pause the video just so you can get that typed into your calculator and then make sure you get the right answer. I've already done that calculation, so the answer comes out to be 5.5, or if you want to write it as a fraction, 11/2. So because of the way that the bases of the successive trapezoids in a trapezoid rule problem, they always overlap. So the only ones that don't overlap is the very leftmost base and the very rightmost base. So your starting base and your stopping base. In other words, the starting and stopping points on your x-axis, those heights of the function there. So if you want, we can generalize the trapezoidal rule to be this formula. So in general, the trapezoidal rule for area is that the area is approximately 1/2 times your delta x, right, that's your b minus a all over n, times f of x1 plus 2 times f of x2 plus 2 times f of x3, right, all the way out, dot, 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 to 2 times f of x to the n minus 1 plus f of xn right, and that's going to be true for n equals subintervals. So in order to use this formula, they do have to be equal subintervals, otherwise you have a varying delta x, so you can't have it factored out in front. So those subscripts x1, x2, x3, and out to xn, they're just saying like this is the first x value that you're going to use in your interval, this is the second one, the third one, and so on and so forth, right? And if you want to really have a formula here, right, x sub 2 is just going to be x1 plus your delta x, right? This is just x1 plus 2 times delta x, so on and so forth. So you could also set it up like that if you wanted to do more of a formula kind of thing. You can't write this as a sigma notation because you have those doubling up points.